Hello student, in this class we will learn about this topic. The name of this topic is separating the components of mixtures. Yes my dear student, here we are going to study about the different methods through which we are going to separate the components of a mixture. So let's try to understand all the method one by one. So we will start with the first method, that is my chromatography. So generally we have enough number of methods we have, but generally we are going to focus on the major method that we are using normally, and those methods are extremely important for the exams. So very first we will talk about the chromatography. After that we will talk about the centrifugation. Then after that talk about the separating funnel, then distillation and the fractional distillation. Student, we will also talk about the crystallization method also. So generally we have around 6 methods that we are going to discuss in this class. So students, let's start with the chromatography very first. So in the chromatography, this method is used for separating the components of a mixture. This method was initially used for the separating out the colors which are obtained from the natural sources, just like flowers. So thing is that as you can see here in this method, as you can see, the glass jar is used. In that glass jar I am going to use a paper strip and I am going to use a suitable solvent here. So very first thing, try to know something about the chromatography here. Chromatography is a process, okay, this is a separating process, okay, we are separating the different components of a mixture here, okay. It can also be used as a purification tool. So let's say if my color, for example, take a very simple example. Every student is using a black color ink. Obviously they are using the black color ink, but this black color ink is made from multiple colors, as you know that very well. So just to separate all the color which can make the black color, that can be separated out by this chromatography method here. So in chromatography method, the one of the important aspect of this method is that we have a mobile phase here, which is your solvent, and another we have the stationary phase. That could be your paper strip, maybe a glass plate. On that suitable substance is plated, a very thin layer is going to applied on that. That is called my stationary phase. So there are two phases are there. One is mobile. Mobile means which is movable. Stationary means which is not movable here. So stationary and mobile phase, even I can use the column, a glass column which is completely packed with the chalk or any kind of silica gel. That can also be used here as a stationary phase here. So my dear student, chromatography is nothing but it's a combination of stationary and the mobile phase here. So as the solvent is going up, because solvent is going to absorb on the stationary phase. Here example, as you can see here in this image, as you can see here, our stationary phase is your glass strip or maybe a paper strip here. So paper can absorb the solvent here. As solvent is moving up, it will carry all the constituents of your mixture here, and every constituent has different absorption rate on this stationary phase. So what will happen, as they have different absorption rate, they are going to separate out in the phases here and they will cause a graph of color. So that is called the chromatography. Student, I hope you are understanding this. Chromatography is a separating method. Even we can separate out the pure substance here from the mixture of the components here. So student, the next method that we are talking about, that is the centrifugation. So this centrifugation method is used for the solutions of the mixtures here, having in which two components have different in their densities. So one of the major principle or one of the major criteria for this method is what? Density, difference in their densities. This is one of the major criteria for this method. So now where I can use this method? Yes my dear student, this method you have seen so many times in your house also. For example, to separate butter from the cream. Yes, my dear student, you have seen this method so many times at your home, as I told you already. But apart from it, has one of the vital and the critical application also. For what? For centrifugation method. That is for the purification blood and urine test also. So generally all the pathology labs or diagnostic labs, they are doing the centrifugation method for simply testing or analyzing the urine and blood samples. So generally what happens in that, generally this is your centrifugation device here. We need to rapidly rotate all the tubes which is containing our mixture here. What will happen here? The principle of this method is what? The density, the difference in the density of my two components here. So what will happen? This is my before, as you can see here, everything is mixed here. The blue and the black dots are mixed here. But after centrifugation, what will happen? As you can see here, the black dots are separated here only and another substance is on the top here only. Because we have a different in the densities. One component is heavier in nature, another component is lighter in nature. So heavier component is going to settle down at the bottom here, and the top one, which is lighter in nature, which is going to settle down on the top. So here is the method that is called the centrifugation, and this is all carried by the centrifugation apparatus. So my next method is separating funnel. So separating funnel method is used when I have a mixture of two immiscible liquid. Immiscible liquids means they are not going to mix with each other. I can give you one simple example here when I am going to mix water and oil here. So what will happen? Oil and water, they cannot mix. Even you cannot dissolve oil in water or water in oil. They are going to separate out in two distinct layers. If I am having these kind of liquids with me, definitely how can I separate those kind of liquids? Here is the answer. Answer is the separating funnel. So this method depends on the densities of two liquids here, miscible involved in a solution here. So generally in the separating method, as you can see here, separating funnel is used. This funnel is made from the borosilicate glass, and here we have to hang this borosilicate separating funnel in this fashion. So on the bottom portion of that you will find one knob here, that is my start and off knob. Here I am going to fill the oil and water mixture here from the top. This is the opening, this is the inlet for that. What will happen here? First of all, I am going to take out the component which is on this side also. Then after that I will wait for the another component, then I will take it out in another beaker also. Let's say for example, if I am mixing water and oil, what will happen? What will happen in that situation? So I am going to fill that water and oil mixture here, then after that I can separate out both the components one by one here using the separating funnel. So the basic principle for this method is that immiscible liquids means they cannot mix very nicely or readily with each other. So this is all about the separating funnel here. The next funnel is very important, that is my distillation method. The method of distillation is used for the separation of the miscible liquids that have a large difference in the boiling point. So this is my actual, or you can say the real principle, or you can say the ultimate goal of my distillation method. Thing is that, let's say I am having two liquids and I want to separate them, those two liquids. Okay, and let's say for example I have enough difference in their boiling point, maybe more than 25 degrees centigrade or maybe more than that also. If I am having a sufficient amount of difference in their boiling point, then I can use this distillation method very nicely to separate them out. So in this method, as you can see here, this is the entire setup of this. As you can see here, this is my Bunsen burner, this is my tripod stand, this is the round bottom or the flat bottom flask, or here we have the thermometer just to check or just to find out the temperature here. This is my condenser here. For example, here we have the cold water inlet and this is my outlet also. So this is my condenser here. What will happen? The vapors will come up here. This is my distillation flask. Another term that I can use it here for the distillation. This is my distillation flask here. So what will happen here? Because as water is flowing here, what will happen? The vapors which are going up here, it will get cool and it will come in the form of the liquid here. So student, in this method what I am using here, the difference in the boiling point. The difference in the boiling, and it should have enough difference in my boiling point, then I can use the distillation method here. So typically in all the distillation method I am going to use the same kind of setup here. So this method is very simple. Simply you have to arrange all this thing in this fashion. But remember that your two constituents or two components must have a enough difference between the boiling point. If it is not there, then what should I do in that situation? The answer is here. This method is used to separate a mixture of two or more miscible liquids having the difference in boiling point to be less than 25. Yes, my dear student, if my component is not having the difference 25 degrees centigrade, then what will happen? I will use the fractional distillation method. Fine. If a boiling point is less than 25, I am going to use the fractional distillation method. So this method is used by using a fractionating column. This fractionating column is available in lot of designs, in lot of options also. So basically this could be a glass tube which is packed with the glass beads also. This is another way. One of the classical and one of the best example of the fractional distillation is the fractional distillation of crude oil. As you are all aware about that, petrol, diesel, kerosene, or you can say the paraffin waxes, heavy oil, naphtha, all are obtained from the crude oil. So crude oil is subjected to the fractional distillation, and this crude oil can give you a lot of products which are extremely useful for the mankind. For example, petrol, diesel and kerosene, as you are all aware about it. Even without that we cannot survive. Thing is that, see, this crude oil is working only on the fractional distillation because their components, let's say for example, if I am talking about the diesel, kerosene, petrol, their boiling points, they are very similar. We are near to each other. You will not find more than 25 degree centigrade difference in that. So for just to solve that, I am going to use the fractional distillation method also. So student, here is a typical image here that is going to explain you the entire process of the fractional distillation here. The only difference that you are going to find out here, I am going to use the fractionating column here, and apart from that all the setup is same as we have seen in the distillation method here. So now student, after that we will talk about the sublimation method. This sublimation method is based on purely only one concept. What is that actually? If your one of the component is having ability to sublimate. What is the meaning of sublimation? Have you seen camphor in your life? Have you seen any kind of naphthalene balls in your life? If I am going to keep it open, what will happen? They will convert directly into the vapor form. Okay? No liquid state will come. Solid is going to convert into the vapor form, or you can say in the gaseous form without converting or coming into the liquid form. That property is called the sublimation. So generally solids have tendency to convert directly into the gaseous state without converting into liquid. Without converting into liquid, this is another important point. Okay, now if I am having this kind of solids with me, so on heating, this process is called as the sublimation actually. Okay, so generally most of the solids are showing this kind of property. Example, as I already told you, the camphor. Another example is my ammonium chloride, which is available in the chemistry lab. Naphthalene balls you have seen so many times in your life also. And another is anthracene. Please try to remember the examples of the compound which are showing the sublimation property. So here in this method, what will happen? Say if I am having the ammonium chloride plus salt mixture here. See, ammonium chloride has property of sublimation here. So if I am going to heat this compound here, and see, this is my inverter funnel here. I am going to close this funnel here from the top with the cotton plug here. What will happen? Ammonium chloride will evaporate, is convert into the vapor, and it is going to store here, as you can see here. And what will happen? The salt will be here only. Then afterwards, I can carry out the process here. I can take out all the ammonium chloride which is going to deposit here. So here I can separate out the ammonium chloride and the salt mixture here with the help of the sublimation method here. So student, another method is the crystallization here. Crystallization is the process that separates the pure solid in its crystal from the saturated solution. Okay, here I can get the pure substance here if I have the saturated solution of it. So this method is employed to purify the solids also. So one of the classical example and one of the best example is that the salt. If I am talking about salt, means common table salt, sodium chloride. And generally we are going to obtain it from the seawater. Okay, so generally it has many impurities in it. So just to remove all the impurities, all impurities from it, they are going to use the crystallization process here. So crystallization process will give me the solid NaCl, or maybe you can say the pure NaCl that I am going to use. So here is the diagrammatical presentation of the crystallization process here. First of all, I am going to prepare a saturated solution here. In the second step, simply I am going to boil it so that most of the solvent is going to evaporate. Then after that, I have to wait it for some time. My substance is converted into the crystalline form here. Then what will happen? I am going to dry dip on the filter paper. So finally in the stage 4, I am going to get the pure crystals of my NaCl here. So student, we have seen the crystallization method. Now student, we have seen all the methods through which I am going to separate out all the components of mixture here. So student, thanks for watching this.